Welcome to Chemistry for Engineers. Our lesson for this episode is on cell potentials under standard conditions. These are a couple of sample calculations regarding the concept of cell potentials under standard conditions. We recall that by doing experiments such as that illustrated in our previous lessons, we not only have a notion of the relative oxidizing and reducing abilities of various chemical species, but we can also rank them quantitatively. Now, if your E naught cell is the measure of the standard potential for the cell, then the reduction potential of the cathode and the reduction potential of the anode are the measures of the electrode potentials in both the cathodic and the anodic half cells of a voltaic cell. And because your E naught, or the EMF of the cell, reflects the difference in electrode potentials, the EMF of the cell must be the difference between the reduction potentials of the cathode and the anode, as illustrated by the equation. And so in this lesson, or in this part of our lesson, we will be determining the cell EMF given our reduction potentials of the cathode and the anode. Now, the cell EMF, or the electromotive force of the cell, is the net voltage between the oxidation and the reduction half reactions taking place between two redox half reactions. And in fact, cell EMF is used to determine whether or not the cell is galvanic. So this sample problem shows how to calculate the cell EMF using your standard reduction potentials. So the table of standard reduction potentials, or the table of SRP, is needed for these examples. In a homework problem also, you should be given these values or else access the table. Okay, so we are now to consider the net reaction occurring in a voltaic cell using silver and copper half cells described by the equation. And we are asked if the reaction occurs in standard conditions such that the reduction potentials are given as follows, then we are to calculate the cell EMF. And of course, letter B, identify if the reaction taking place is galvanic in nature. Now, apparently, our first step, although not asked directly by the problem, is to identify the cathode and the anode, and that is to determine the two half reactions, whether which one is reduced or oxidized. In this case, we have two half reactions. One is for silver and the other is for copper. And in this case, we know that your silver is reduced. No? So the silver ions is reduced to um, a solid, no, silver metal. And so we say that your silver electrode is your cathode. And consequently, your copper metal is oxidized to copper 2 plus ions. And so we say that copper is now in the anodic half cell. And so it now is the anode. And we also recall that the oxidation always occur at the anode and reduction reactions are occurring at the cathode. Now, based on definition, okay, we know for a fact that the potential of the cell in under standard conditions, and that we call that the standard EMF, it's just equal to the reduction potential of the cathode minus the reduction potential of the anode. In this case, our cathode is our silver reaction and our anode is our oxidation of copper. And so we will use the values of these two half reactions, the EMF or the reduction potentials of the two half reactions, to determine our standard cell potential. And to do so, we will just use the values given in the problem. So we have here a straightforward calculation wherein we are using the values given in the problem. And in fact, these values is also found in the table of SRP that is already given to you. And so in here, we find that the standard cell potential is a positive value. And so for letter B, we are asked if this um, if this cell, no, with the characteristics that is defined by the chemical equation is either galvanic or not. So since it has a positive cell potential, so we say that this cell is galvanic or voltaic in nature. Now, apparently, okay, we could use the table of SRP to calculate for the cell EMF of voltaic cells. In this case, we will be determining the value of the cell EMF, which is described by the reaction. So, step 1 ulit. Now, we are given the equation for a redox reaction, and we are asked to use the data in the table of SRPs that we give. And so we are also going to calculate the standard cell potential for the associated voltaic cell. So para ma-simplify, okay, so our first step, of course, is to find which of the elements satisfy a cathodic reaction and which one satisfies an anodic reaction. In this case, our cathodic reaction is the reaction for chromium, and then our anodic reaction is the reaction of our iodine. And so, from the original equation, which defines that the cell potential is just the difference of the reduction potentials of the cathode and the anode, so we will substitute the values of the reduction potentials of the two half equations, or half reactions, I mean. And consequently, according to the table of SRP, we have the following values for the reduction potential. And so we find that the cell has a total, and a cell potential under standard conditions of 0.79 volts. Now notice that although we must multiply the iodine or iodide half reaction by 3, okay, notice this one. Meron siyang coefficient na 3. So, if we're going to follow mathematical rules, we could multiply. We could multiply the iodide half fraction by 3 to obtain a balanced equation. But then, we do not multiply the reduction potential values by 3. And as we have noted in earlier discussions, the standard reduction potential is an intensive property. And so, independent siya of the stoichiometric coefficient. So, whether umabot yan ng 30, 10, o kahit pa gaano karami or gaano kalaki yung iyong stoichiometric coefficient, still, it will not affect the EMF value of the half reaction. Now, if we're going to check the cell potential, so we have a positive value for our calculation. And as noted earlier, this is a voltaic cell. And so we are sure now that the potential that we got is correct, because one of the characteristics for a cell to be considered voltaic or galvanic is for it to have a positive EMF or standard standard cell potential. Okay. I hope that I have given you more examples. So it's two more examples from the previously given one in the actual lesson or discussion. But then if you want more, you can use the book of Brown on chemistry, the central science. You could have the 7th edition and also the chemistry for engineering students 2nd edition.